Igneous rock definition. Igneous rocks are one of the three main types of rocks, alongside sedimentary and metamorphic rocks, and are formed through the cooling and solidification of molten rock material, known as magma or lava. Magma originates deep within the Earth's mantle, where high temperatures and pressures cause rock to melt. When magma erupts onto the surface through volcanic activity, it is called lava. Depending on where the cooling process occurs, igneous rocks are classified into two main categories. Intrusive, plutonic, igneous rocks. These form when magma cools and solidifies slowly beneath the Earth's surface. The slow cooling process allows large crystals to develop, giving these rocks a coarse-grained texture. Examples include granite, diorite, and gabbro. Extrusive, volcanic, igneous rocks. These are produced when lava cools and solidifies rapidly on the Earth's surface, often as a result of volcanic eruptions. Due to the quick cooling, these rocks usually have small or no visible crystals, resulting in a fine-grained or glassy texture. Examples include basalt, rhyolite, and obsidian. Igneous rocks are composed primarily of silicate minerals such as feldspar, quartz, mica, and pyroxene. Their mineral composition and texture can vary greatly, depending on the chemical composition of the magma or lava and the rate of cooling. These rocks are critical to understanding the Earth's geological history, as they provide information about volcanic processes, plate tectonics, and the composition of the Earth's interior. They also have significant economic value, serving as sources of building materials, industrial minerals, and ores for metals like copper and iron. Formation of igneous rocks. Igneous rocks are formed through the cooling and solidification of molten rock material known as magma or lava. This process can take place deep within the Earth's crust or on its surface, depending on whether the molten rock remains underground or is ejected during volcanic activity. The formation of igneous rocks involves several key stages, and the characteristics of the resulting rocks are determined by factors such as the cooling rate, mineral composition, and location of the formation. 1. Generation of magma. The formation of igneous rocks begins with the generation of magma. Magma is created when rocks in the Earth's mantle or lower crust melt due to specific conditions. Increased temperature, heat from the Earth's core or from nearby magma chambers can raise the temperature of rocks, causing them to melt. Decreased pressure, at tectonic plate boundaries, such as mid-ocean ridges or continental rifts, a reduction in pressure allows rocks to melt at lower temperatures, a process called decompression melting. Addition of volatiles, water and other volatile substances, when introduced into the mantle, such as at subduction zones, can lower the melting point of rocks, leading to magma formation. The resulting magma is a mixture of molten rock, gases, and sometimes suspended crystals. Its chemical composition can vary widely, producing magmas that are rich in silica, felsic, or poor in silica but rich in magnesium and iron, mafic. 2. Movement of magma. Once formed, magma begins to rise towards the Earth's surface due to its lower density compared to the surrounding solid rock. As it ascends, magma may collect in reservoirs called magma chambers. During this process, the magma may undergo chemical changes through fractional crystallization. Minerals with higher melting points crystallize out first, altering the composition of the remaining magma. Assimilation. Magma can incorporate surrounding rock material as it moves upward, further changing its composition. 3. Cooling and solidification. The cooling and solidification of magma or lava lead to the formation of igneous rocks. The cooling process can occur either underground or on the Earth's surface, resulting in two primary types of igneous rocks. A. Intrusive, plutonic, igneous rocks. When magma cools and solidifies slowly beneath the Earth's surface, it forms intrusive igneous rocks. The slow cooling allows large crystals to grow, resulting in a coarse-grained texture. Common examples include granite, rich in quartz and feldspar. Diorite, intermediate in composition. Gabbro, rich in dark, mafic minerals like pyroxene and olivine. These rocks are often exposed at the surface after millions of years of erosion remove the overlying material. B. Extrusive, volcanic, igneous rocks. If magma reaches the surface as lava, it cools and solidifies quickly, forming extrusive igneous rocks. Rapid cooling prevents the growth of large crystals, resulting in a fine-grained or glassy texture. Examples include basalt, a dark, fine-grained rock that forms from mafic lava. Rhyolite, a felsic rock with a fine texture. Obsidian, a glassy volcanic rock that forms when lava cools almost instantaneously. 4. Textures of igneous rocks. The texture of an igneous rock is directly related to its cooling history. Coarse-grained texture, found in intrusive rocks due to slow cooling. Fine-grained texture, found in extrusive rocks due to rapid cooling. Glassy texture, occurs when lava cools so quickly that no crystals can form, as in obsidian. Porphyritic texture, a mixture of large crystals, phenocrysts, and fine-grained material, indicating a two-stage cooling process. 5. Distribution and geological importance. Igneous rocks are found in a wide variety of geological settings. Divergent plate boundaries, magma emerges at mid-ocean ridges, forming new oceanic crust. Convergent plate boundaries, subduction zones produce magma that forms volcanic arcs and associated intrusive rocks. Hot spots, mantle plumes can create volcanic islands, such as Hawaii, through the eruption of basaltic lava. These rocks are vital to understanding the Earth's geological history because they preserve information about the conditions and processes within the Earth's interior. They also play a crucial role in the rock cycle, providing raw material for the formation of sedimentary and metamorphic rocks. 6. Significance of igneous rocks. Geological insights. Igneous rocks reveal details about plate tectonics, volcanic activity, and the Earth's mantle composition. Economic value. Many igneous rocks are sources of valuable minerals and metals, such as gold, silver, copper, and platinum, as well as industrial materials like basalt for construction and granite for decorative purposes. In summary, the formation of igneous rocks is a dynamic process that begins with the melting of mantle or crustal material and ends with the solidification of magma or lava. Their diverse compositions and textures reflect the wide range of conditions under which they form, making them an essential component of the Earth's crust. Examples of igneous rock. Igneous rocks, formed from the cooling and solidification of molten rock, magma or lava, come in a wide variety of types based on their mineral composition, texture, and formation environment. These rocks are classified into two main categories: intrusive, plutonic, and extrusive, volcanic, each with distinctive characteristics and examples. Below are detailed examples of common igneous rocks. Intrusive, plutonic, igneous rocks. Intrusive igneous rocks form when magma cools slowly beneath the Earth's surface, allowing large crystals to develop. These rocks typically have a coarse-grained texture due to the extended time for crystal growth. 1. Granite. Composition. Granite is a felsic rock composed primarily of quartz, feldspar, plagioclase and orthoclase, and mica, biotite or muscovite. Color. Light-colored, often pink, white, or gray, due to its high silica content. Uses. Widely used as a construction material, for countertops, and as decorative stone in monuments and buildings. Occurrence. Commonly found in continental crust, often forming large plutons or batholiths. Examples of locations: the Sierra Nevada in California and the Scottish Highlands. 2. Diorite. Composition. Intermediate in composition, diorite contains plagioclase feldspar, biotite, hornblende, and small amounts of quartz. Color. Medium to dark gray, with a salt and pepper appearance due to interspersed light and dark minerals. Uses. Used in construction, particularly as crushed stone or for decorative purposes. Occurrence. found in continental volcanic arcs and intrusive bodies near subduction zones. Examples of locations: Andes Mountains in South America. 3. Gabbro. Composition: a mafic rock made of plagioclase feldspar, pyroxene, and olivine, with very little quartz. Color: dark gray to black due to the dominance of mafic minerals. Uses: often used as crushed stone for road construction and as a dimension stone. Occurrence: common in oceanic crust and found in layered intrusions. Examples of locations: Bushveld Complex in South Africa and Sudbury Basin in Canada. 4. Peridotite. Composition: an ultramafic rock made predominantly of olivine and pyroxene, with very low silica content. Color: greenish due to the high olivine content. Uses: peridotite is an important source of the gemstone peridot and is studied to understand mantle processes. Occurrence: found in the Earth's mantle and as part of ophiolite complexes. Examples of locations: Oman ophiolite and the Pyrenees. Extrusive, volcanic, igneous rocks. Extrusive rocks form when lava cools rapidly on the Earth's surface, resulting in small crystals or even glassy textures. These rocks are often associated with volcanic activity. 1. Basalt. Composition: a mafic rock composed of plagioclase feldspar, pyroxene, and olivine. Color: dark gray to black due to its low silica content and abundance of mafic minerals. Uses: commonly used in construction, road paving, and as aggregate in concrete. Occurrence: basalt makes up the bulk of the oceanic crust and is frequently erupted at mid-ocean ridges and hot spots. Examples of locations: Hawaiian Islands, Iceland, and the Columbia River Basalt Group in the USA. 2. Rhyolite. Composition: a felsic rock with high silica content, composed primarily of quartz, feldspar, and mica. Color: light-colored, white, pink, or pale gray, due to its high silica content. Uses: rhyolite is less commonly used in construction but can be an indicator of past volcanic activity. Occurrence: found in continental volcanic arcs and caldera systems. Examples of locations: Yellowstone National Park in the USA. 3. Andesite. Composition: an intermediate rock containing plagioclase feldspar, pyroxene, and amphibole. Color: gray or brown, with a fine-grained texture. Uses: used as crushed stone in road construction and sometimes in sculpture. Occurrence: found in volcanic arcs above subduction zones. Examples of locations: Andes Mountains in South America and Mount St. Helens in the USA. 4. Obsidian. Composition: volcanic glass with a high silica content, but it lacks a crystalline structure. Color: black or dark brown, with a glassy, shiny appearance. Uses: historically used for making sharp tools and weapons. Today, it is used in jewelry and ornamental objects. Occurrence: forms from rapidly cooled felsic lava. Examples of locations: Crater Lake in Oregon, USA, and Lipari Island in Italy. 5. Pumice. Composition: a highly vesicular, light-colored volcanic rock with high silica content. Color: white, gray, or pale yellow. Uses: used as an abrasive material in cleaning and polishing products, as well as a lightweight aggregate in construction. Occurrence: forms during explosive volcanic eruptions when gases trapped in the lava create a frothy texture. Examples of locations: Santorini, Greece, and Mount Vesuvius in Italy. 6. Scoria. Composition: a mafic volcanic rock with abundant vesicles, typically composed of basaltic or andesitic material. Color: dark red to black. Uses: commonly used as landscaping material and for drainage in construction. Occurrence: found in volcanic cones and lava flows. Examples of locations: Mauna Kea in Hawaii and Paracutin in Mexico. Uncommon igneous rocks. Tuff, a rock composed of volcanic ash and debris ejected during explosive eruptions. Found near caldera systems. Pegmatite, a very coarse-grained intrusive rock with exceptionally large crystals. Often rich in rare minerals like tourmaline or lithium. Summary. Igneous rocks exhibit a wide variety of compositions and textures, reflecting the conditions under which they formed. From the coarse-grained granite of mountain ranges to the glassy obsidian formed by rapid lava cooling, these rocks are integral to understanding Earth's geology. Their economic uses and geological significance make them a cornerstone of study in earth sciences.